Hello students, today we are going to discuss about chemical properties of metals. In that one, first one is metals react with oxygen atoms. Okay, so metals react with oxygen atom, it will form metal oxides. Metals react with oxygen atom forms metal oxides. Okay, now these metal oxides are two types. One is basic metal oxide and second one is amphoteric metal oxides. Generally, all metal oxides are basic in nature. Basically, all metal oxides are basic in nature, and whereas the two metal oxides are there which act as a amphoteric in nature, those are aluminum oxide and zinc oxide. Okay, now let us see how oxygen react with metal. Does this oxygen react with all the metals with equal proportion? No. So when I'm taking the reactivity series, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead. Okay, when I'm taking the reactivity series here, uh, with potassium and oxygen, for sodium and potassium, oxygen react vigorously. With potassium and sodium, oxygen react vigorously, even it catches fire. It catches fire means the reaction is very vigorous, so that even at atmospheric at, oxygen also these two metals catches fire. Because of that reason, potassium and sodium they kept under kerosene, they preserved under kerosene because they are highly reactive. Okay, so that's the reason sodium and potassium they kept under kerosene. Okay, and other metals when they react with oxygen atom they will form calcium oxide, and magnesium react with oxygen atom form magnesium oxide, metal oxides. Aluminium react with oxygen atom form aluminium oxide. Zinc react with oxygen atom form zinc oxide. Like that, the metals combined with oxygen atom they are giving metal oxides. Metal oxides. So basically, when you see the few metals like aluminum, iron, zinc, lead, these metals, when you keep it for some times in the atmosphere, these metals develop one oxide coating layer. This is called oxide coating layer. These layer prevent the further oxidation of this metal. Okay, so when you leave this aluminum, iron, zinc or lead metal for some times in the atmosphere, they react with atmospheric air and they develop one oxide layer surrounding the surface of this metal. Okay, so that oxide layer stop the further oxidation of this metal. Okay, so these metal oxides are basic in nature. So generally the metal oxides are not soluble in water. Metal oxides are not soluble in water, but only very few metal oxides which are soluble in water. What are those metal oxides which are soluble in water? Sodium oxide and potassium oxides. So sodium oxide, sodium react with oxygen, gives sodium oxide, and potassium react with oxygen and gives potassium oxide. Okay, sodium oxide and potassium oxide soluble in water, and other oxides are not soluble in water. Okay, so metal oxides, metal oxide which are soluble in water, soluble in water are known as alkali. To whom we call them as alkali? The metal oxides which are soluble in water is known as alkali. Okay, now apart from these metal oxides, what are the other form of the metal oxides? Those are amphoteric oxides. Okay, so let us see what are the amphoteric oxides and how we can define them. Okay, so amphoteric oxides. Example for amphoteric oxides, we have aluminium and zinc metal. Aluminium react with oxygen atom and form aluminium oxide. In the same way, zinc also react with oxygen, form zinc oxide. Okay, so to balance this, how can I say balance? First, we need to balance oxygen atoms. Here, three oxygen atoms I'll keep. 3 to the 6 oxygen atoms are there. Okay, so now here 6 oxygen atoms are there. 3 2s are 6 oxygen atoms are balanced. Now how many aluminum atoms are there here? 2 2s are 4. So 4 aluminum atoms are balanced. Okay, and this reaction is automatically it was balanced. So these oxides, aluminum oxide and zinc oxide, they call them as amphoteric oxides. Why they are calling as amphoteric oxide? Because these oxides behave as acidic as well as basic in nature. The oxides which behave as acidic as well as basics. Okay, oxides behave as acidic as well as basic in nature, or call them as amphoteric oxide. Now, how these amphoteric oxides they react with acid on bases? Let us see now. Okay, with examples. First example, aluminum oxide react with acid. Okay, so now I am taking here what acid, and here it is a, if I am taking acid, then it will become as a base. Okay, then what it will form? AlCl3 plus H2O. That means it is formed salt and water. It is a kind of neutralization reaction. So that means amphoteric oxide react with acid, form salt and water. Or even you can say amphoteric oxides are the oxides which react with acid medium or basic medium and gives salt and water are known as amphoteric oxide. Okay, now let us balance these aluminum atoms. Number of atoms are 2 here, number of atoms here 2 balance. Okay, number of oxygen atoms are how many here? 3. Okay, so here how many? 2 3s are 6 aluminum atoms are there. Okay, so 6 chlorine atoms are there, and I have to balance this chlorine atom also and this oxygen atom also. Okay, now how can I balance now? 2 3s are 6. So I'll make it as a 6. 6 chlorine atoms, 6 chlorine atom balance. Now here 6 hydrogen atoms are there, here 2 hydrogen atoms are there, it will balance with 3. So now reaction was balanced. Okay. So now 3 oxygen atoms, 3 oxygen atoms, 6 hydrogen atoms, 6 hydrogen atoms, 6 chlorine atoms, 6 chlorine atoms balance. Okay. Similar way, when I am taking aluminum oxide in basic medium, it gives NaAlO2 plus H2O gas. This is a salt and this is water. Sodium aluminate and water. So we can define amphoteric oxide in another way. The amphoteric oxides are the oxides which react with acid as well as base to give salt and water are known as amphoteric oxides. Okay, so generally metal oxides are basic in nature and few metal oxides are amphoteric in nature. Example of metal oxide amphoteric nature is zinc oxide and aluminum oxides. Okay, and especially sodium and potassium metals react with the oxygen vigorously. That means very fast, and it catches fire at room temperature. Okay, that is the reason the potassium or sodium metals they kept immersed in kerosene or paraffin wax to avoid contact with oxygen atom. Okay, and other metals like zinc, aluminum, iron, lead, these metals develop oxide layer upon the surface of the metals when you kept for a long time in open atmosphere. And this is about metal oxides in this. Okay, thank you.